Today we're going to be looking at Chapter 13, the division of polynomials. You either have long division or synthetic division. We'll talk about the couple of differences and when you can use either one. The P stands for just the polynomial. So we know the polynomial is equal to D. Well, the D, I'm going to do some abbreviation here, stands for the divisor, times Q. Well, that's the quotient. And then plus R. That's the remainder. So it kind of tight squeeze in there, but that's what each of those things are. Polynomial is equal to the divisor times the quotient plus the remainder. That's just a way that you can write that. And we know that a root or solution of the polynomial, f of x equals 0, is a number r such that f of r equals 0. So what's that telling you? Well, that's telling you that when r equals 0, then we know that we can, when the remainder is 0, then we know that we can have a root. Okay, so when we're doing our division, that's what we're looking to get. If we can get that remainder to be 0, then we can go ahead and we can look at finding factors of a polynomial. Okay, now for synthetic division, as you can see, we can only use it when you have the format of x minus a. We'll talk about that in just a couple minutes. All right, so let's take a look at some examples that we got here. And we'll start with this first one right here. All right, so our goal is to get a remainder of 0 if we can, because then we know it's a factor, and then we can go through and we can talk about what are the factors, and then we can find the zeros of that particular polynomial, which is the ultimate goal. Within the next few days, we're going to be looking at that. Okay, so what I'm going to do is for this first one is I'm going to start off just doing long division, because probably be a little review that we need to do. So x minus 5 is my divisor, and I wanted to divide it into x cubed minus 4x squared plus x minus 2. So the first thing I'm looking for is what times x gives me x to the third power? Well, that's just positive x squared. So I multiply that group by that x minus 5 group by x squared, and I'm going to say, okay, well, that gives me x cubed minus 5x squared. And here's the tricky part for students is you are going to subtract the quantity. So x cubed minus x cubed cancels. Negative 4x squared minus negative 5x squared gives you a positive 1x squared. So please be careful with those negatives. Okay, drop down the x. And again, what times x gives me x squared? Oh, that's just a positive x. So x minus 5 times x gives me x squared minus 5x. Again, I'm going to be subtracting the quantity. So that'll go away. X minus negative 5x gives me a positive 6x. Drop down the negative 2 because I'm not done yet. So what times x gives me 6x? Well, that's a positive 6. If I multiply x minus 5 times positive 6, I get 6x minus 30. Again, you are subtracting the quantity. So 6x is canceled, and this students make the trickiest part, so be careful. Negative 2 minus negative 30 ends up giving me a positive 28. And since I can't divide by x minus 5 any further, that is my remainder. All right, so obviously it's not 0 like we wanted, but that's okay. We still get a positive remainder there. So now here's all about how you write your answer. As I talked about in the beginning, right? Sometimes they're going to want your answer in that format. Okay, where you say the polynomial is equal to the divisor times the quotient plus the remainder. So you just got to look carefully. So I can say that my answer is going to be the divisor, x minus 5, times the quotient. The quotient is what you got as your answer up there. So times the quantity of x squared plus x plus 6. And then I can just add the remainder of 28. And so right here, here's the answer that I would get if I were to write it in the format that we listed up above there, okay, that I've underlined a couple times. The other format that I've seen, or you possibly have seen in your class, is they maybe have just done to write down what is the quotient. So x squared plus x plus 6. Here's the thing that students forget, but you're not going to. You remember this. Plus, you can say, well, what's the remainder? Well, it's 28 divided by x minus 5. And this is sometimes the answer that we're going to be looking for. So please make sure you're looking for that. This would be like the quotient plus the remainder over the divisor answer. All right. So it just depends on if the directions are given to you, how you need to write it. Otherwise, this typically is what you'll see as an answer if it's multiple choice or what you want to do for your tests and quizzes. Okay. So make sure you look carefully what's asking for. All right. So that's just a review of long division. Hopefully you remember that. May have been painstaking for some of you, but remember the biggest thing is that you have this minus the quantity. That's the part that you're going to have to remember to do. Okay. Now, we also said that you can go through, and this is a prime candidate for synthetic division because you had the x minus 5 group there. Okay, we're going to change the color a little bit. All right. So because we have the x minus 5, I can do synthetic with this. Now, if you think about it, if you take x minus 5 and you set equal to 0, well, what comes from that is that x equals 5, and there's different formats for your synthetic division. What I learned back when I was your age is to write that 5, because you would get x equals 5, and that 5 I'm going to put in the box. Like I said, I know there's different formats. I've seen some from different teachers. Do whatever format's familiar with you. I think there are some people that, and I'll try and squeeze it up here, that do 5 and they make it like this. Whatever you want to do, it's fine with me. It's up to you what you're familiar with. But I was just told, okay, put that 5 in the box. Now we're going to take all the integers or the coefficients and the constant. We're going to put them in order. So I'm going to say 1, -4, +1, -2. I'm just going to do some synthetic division right there. I drop down the 1, bring down the first number. I take that number and I multiply whatever number is in the box. So in this case, 1 times 5. And I'm going to put it into the next spot. I'm going to get a 5 there. I add straight down. I get a +1. Again, I'm multiplying by the number in the box. So 1 times 5, it's going to go up here, and I'm going to get a 5 there. I add straight down. I get a 6. I multiply 5 times 6 because that's the number in the box. I get a 30. If I add straight down, I get 28. And that last number is your remainder. And if you look, if you take this information, right, and we started with x to the third, okay, so when we started this, we had x to the third was the given. When you divide, you always deduct 1. So you get x squared. And so when I write this answer, I'm going to say, oh, look, I have x squared plus 1x plus 6. There's my remainder. So I'm going to say that's plus 28 over x minus 5. It's kind of like if I asked you to take, 7 divided by 3, and you say, oh, 3 goes into 7 2 times with a remainder of 1. So you write that as 2 and 1/3, right? Kind of the same idea. So that's kind of what we're doing here. And if you look, you get the exact same answer as you did previously. Somebody's saying, well, then why would I spend time doing long division? I wouldn't. An example like this, if you have x minus 5, x is to the first power, then I would definitely just do synthetic division. Okay, so it all just depends on what's given to you, what the divisor is in order to make that decision. All right, so I wouldn't waste time on long division unless you have to, and we'll show you some examples in a minute where you're going to have to do long division. But right now, number 2 is another prime candidate as we're going here to look at a synthetic division because it's x minus a number. In this case, the number is I. So what I'm going to do is I know that my divisor is, if I were to set equal to 0 and solve, I would get x equals I. So that's just going to be the number that I'm going to put, as I call it, in the box. Kind of a little divider right there. Okay. I look again, I get x squared, I get 4x to the first plus a constant. I don't need to worry about any zeros. So I have 1 minus 4, +1. I'm going to go through, set up my information. I drop the first number. If I multiply, I get I. Now here's the tricky thing. You might be going, well, -4 and I don't really go together. So you're right. I'm just going to add that and say -4 plus I, and that's an entire group. So I got -4 plus I. Now, if I do a little side work over here, okay. So I'm going to take I times the quantity of -4 plus I. So if I distribute in here, I get -4I plus I squared. And if you remember how imaginaries work, if you have a plus I squared, well, that just becomes a -1. So ultimately, if I write this back on the line, I'm going to have -4I minus 1. So it's not too tricky. You just got to make sure you keep your stuff lined up and organized really nicely. So if I go here, if I add straight down, the one nice thing is the ones cancel, and I'm left with just negative 4i. And that weird looking number is my remainder. So obviously that's not 0. So it says write your answer. I'm going to write my answer. We'll just use the quotient plus remainder over divisor answer. And again, we started with x squared, right? When we did this, we had x squared. So if I drop it down 1, I'm going to have 1x. You don't need the 1, but you can if you want, plus the quantity of negative 4 plus I. That's a weird looking constant, but that's what the constant would be. Now you can write this two ways. I always like to just put plus sign here and then write my entire remainder over x minus I. And as ugly as that looks, that is your answer. Now somebody say, well, Mr. A, do I have to put the plus sign? Can I just put a minus sign there and bring it down in front? Sure. If you'd want to instead, you could say x plus negative 4 plus I. If you want to do this instead, you could do negative 4i over x minus I, right? Either of those would be perfectly fine. You don't need to do that. I always like to put the plus sign to remember to do a minus, especially when you have multiple parts in your remainder. It's kind of nice and easy. You just put a plus sign there and put the negative with the remainder part. Okay, so there's a good review of synthetic division for you. Again, it looks ugly with the I, but let me keep on going. All right, so if you take a look at number 3, here's another prime candidate for synthetic division because you have an x to the first power right there. Here's the tricky thing though. If you look at that x to the 5th, we have a lot of gap in there because really what you have to think of this as is you have to think of this as x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. So we have to take all of those zeros. We got a whole place value when we're doing our synthetic division or long division. Okay, so you need to really be careful with that and identify that first before you set up your information. So x plus 2, so if I set that equal to 0 and solve, I get negative 2. That's the number that goes in my box. And now I got to make sure I put all these numbers. Yes, I do need to include all those zeros. So 1, I got 0x4, 0x cubed, 0x squared, 0x minus 1. And that's when we go through. So once you set it up, the synthetic division, just be careful, right? Drop down the 1, I multiply, I add, I multiply, I add straight down, I multiply. I'm always multiplying by the negative 2, right? That's the number that's in the box. So I add straight down, I multiply, I add straight down, I multiply, I add straight down. So if I was very careful, I got negative 33 as my remainder. So I want to put my answer down. And again, when you're looking at this, you have to identify that it started off as x to the 5th. So when I divide by x to the 1st, I'm going to have x to the 4th. So just start there and say, okay, my answer is going to be x to the 4th minus 2x to the 3rd plus 4x squared minus 8x plus 16. There's my constant. And I'm going to say plus a negative 33 over x plus 2. And there is my answer. And again, if you want to put the minus sign right there, right, if you feel better with that, and then just put a positive 33 on the top of the fraction, that's fine. But you don't have to. You can put plus and the negative, and that means the same thing. Kind of like that better, but it's kind of your choice as you write your answer. All right. Let's try another quick synthetic division. So I got x minus 1 there. I look and I see cubed, squared, x to the 1st, and a constant. So I have no zeros to worry about. So I'm going to put 1 in my box, right? That just comes from solving there. Put my numbers in order. I got 1, a 4, a negative 1, a negative 4. So just get going here. Hopefully you've been practicing. You're getting good at it. So we drop down the 1, multiply. So multiply by 1 to get the 1. I add straight down. I multiply to get the 5. Add straight down. I multiply to get the 4. Add straight down. And I got a 0 remainder. Oh, nice. That's looking for a little smiley face there because that's what we wanted. We wanted the remainder to be 0, right? Because when the remainder equals 0, that tells us that x minus 1 is a factor. That's what we're trying to solve because that'll make a big deal about this in the next few days. So if we can get x minus 1 to be a factor, well, what I need to do is it tells this in the directions. If you find a factor, then your goal is to find the rest of the factor and then the roots. So how do we do that? Well, if I take what was left over here, so it was x cubed, so now it becomes x squared plus 5x plus 4. So I know that that is the quotient. That's the remaining answer as I go through after I do my division, right? It's x squared plus 5x plus 4. So what I'm going to do is just factor that further, because if I got one factor, well, and it got 0 as my remainder, what I know then is that I have a remaining polynomial that I could see if I can try and factor. So if I factor this, I'm going to say, oh, that's pretty easy. That's just x plus 4, x plus 1. If I take that original factor that we found, I know that all of these are the factors to that original polynomial that we started with, right? That original cubic function. And then it says you also got to find the roots. So if I go one step further with this, if I were to basically set each of these equal to 0 and solve, I would get x equals -4, x equals -1, right? All I'm doing is just taking these and I'm setting them equal to 0. This will help me find the roots, right? So -4, -1, and +1. And those are my roots. So again, if it equals 0, that's awesome. We want to equal 0. When it equals 0, then we know, okay, we can factor further. We can find all the factors of that polynomial, which we did in red right there. And then if we take each group, set equal to 0 and solve, then we can know that we can find the roots of that polynomial, right? That the roots, if you remember, that's where the function crosses the x-axis. Okay, so I'm going to start with number 6. Just like we did on the front side to review, say what times 2x makes 6x squared? Oh, that's just going to be 3x. So 3x times 2x gives me 6x squared. If I multiply 3x times 1, I got a positive 3x. And again, you are subtracting the quantity. So I'm going to do the long division first. I'll show you why in just a second. So if I subtract, I got -2x minus 3x gives me -5x. Drop down the 3. Now you got to be careful here. What times 2x gives me -5x? Well, in order to do that is we're going to say that's -5 halves. So please be careful with that. I know some fraction stuff there, but you got to really be careful. So if I take -5 halves times 2x, well, that's -5x. -5 halves times 1, well, that's -5 halves. And again, I'm looking to subtract the quantity. So again, nice things that cancels. 3x minus -5 halves, so that's going to be +5 halves. If you're like, I got fractions, I got, try and add those together. What may be better is if you change this 3, just remember that's the same thing as 6 halves, right? Common denominator. So 6 halves minus a negative, so plus 5 halves gives me 11 halves. There's my remainder. And there's my answer. Okay? Because when you solve it, you're like, oh, if I solve this, right, if I take 2x plus 1, I set equal to 0, I'm going to get that the root comes out to be -1/2. So that's the number I put in my box, right? And then you're like, okay, well, I'm going to take the 6, the -2, and the 3. You say, all right, well, I start doing my synthetic division. I got a 6 there. If I multiply, well, I got a -3. If I add, I got -5. And right away, remember we said, if doing synthetic division or long division, you should get the exact same answer. But right away, you can tell you're not. Here you got a 6. Here you got a -5. We ended up with this, 3x and -5 halves as the correct answer. So you can see right away, doing synthetic division over here does not work as we just did it typically as we did before. That -1/2, that stays in the box. So you have to divide by 2 and say, all right, well, that means I'm going to get 3x squared minus 1 plus 3 halves. So that's the idea, is you have to divide by 2, so you must do that to all of the coefficients on top. Now you can go through and do your synthetic division. Now again, this is what makes doing synthetic division a little bit trickier when you have a coefficient in front there, is because we divided by 2 right here. The second thing that we have to do when we want to write our answer is we now have to multiply by 2 to the remainder in order to have our answer. So this is still 3x minus 5 halves. If you think about 11/4 times 2, Well, that's 11 halves. And since that's a remainder, I'm going to say I divided by 2x plus 1. And there's my answer. You can see it's the same thing.